All right, let's go ahead and do ratios of polyhedrons today. Let's take a look at the congruency theorem. It says two polyhedrons are congruent if all their parts are equal. Let's look at this polyhedron, namely a hexagonal pyramid. Notice that the bases, the lengths are the same. Notice that the heights are the same. And then the sides are the same. All right, because all parts are the same, we say that these two pyramids are congruent. Now let's look at the similarity theorem. It says two polyhedrons are similar if the ratios of their parts are equal. So now we have to look at the ratio of their parts. Let's take a look at these two cones. Remember, we're comparing the ratios of their parts, not just comparing the parts. So let's start off with the diameter. The big diameter is 54. We're going to compare it to the small diameter, which is 18. Always reduce your fractions. 9 looks like it goes into it pretty nicely. 9 goes into 54 6 times, and 9 goes into 18 twice. And of course, that reduces again, 3 to 1. Now let's take a look at the slant height. We have 63 for the big one and 21 for the small one. Reduce it. Looks like 9 goes into that. I mean, not 9. 3 goes into that. 21 times. 3 goes into that 7 times. And if we keep on reducing, we have 3 over 1. Notice that when we reduce their ratios, they are equal to each other. So therefore, they are similar. Here's the symbol for similar. There you go. Let's take a look at the similar solids theorem. If two similar solids have a scale factor of A to B, then their corresponding areas have a ratio of A squared to B squared. We've already done that part. If the sides are A to B, then the areas are A squared to B squared. We did that in the area chapter. The new part is the volume part. It says the corresponding volumes have a ratio of A cubed to B cubed, and that's the new part. Let's go ahead and do an example of these two rectangular prisms. They are similar because of this symbol right here. All right, that means similar, so now we can start comparing them. The first question asks you find the ratio of the sides. Let's go ahead and compare the sides of these prisms. We'll go ahead and compare the 2 yards to the 4 yards. Two over 4, always reduce your answer. We have 1/2. Now if you notice, I could have done it with any of the other sides as well, and it would still reduce down to 1/2. You just want to make sure that you're comparing the correct sides. Short side to short side, long side to long side. Now you have to find the ratio of the surface area. Now there's two ways to do this. You can find the surface area of this whole prism and then find the surface area of this whole prism and then compare the two. But that's quite a lot of work. From the theorem that we had earlier, there was a shortcut where you can take the ratio of the sides and square them. 1 squared over 2 squared, which is 1 over 4. That's a much faster, easier shortcut than having to find the surface area of the whole thing. And then the final thing that I'm going to ask you for is the ratio of the volumes. Again, you can find the volume of the whole thing, and then find the volume of this whole thing, and then compare them. But we do have a shortcut according to the theorem. The theorem says you take the ratio of the sides, and in this case, you cube them. 1 cube over 2 cube. 1 cube is just 1. 2 cube, remember, is 2 times 2 times 2. It is 8. A lot of people forget and think that that's 6, but it is 8. The volume ratio is 1 to 8. All right, let's do another example with these hexagonal pyramids. Let's find the ratio of their sides. And there we have 12 over 9, always reduce. 4 over 3. Let's find the ratios of their surface area. Again, the theorem says you can just square your answer. So 16 over 9. And then to find the ratio of their volumes, you cube your original answer. 4 times 4 times 4. 64. And then 3 times 3 times 3. 27. Now they're going to give you more information. They tell you that the volume of the larger hexagonal pyramid is 600 centimeters cubed. And then now you have to find the volume of the small one. Okay. Since we are dealing with volume of the three ratios, the one that we want to focus on is the volume ratio. The 64 over 27. And now we can put in the 600 with the x. Do a little bit of cross multiplication. You should get 64x is equal to 16,200. And to solve for x, you just have to divide both sides by 64. Final answer is about 253.125. And then I ran out of room, but it is centimeters cubed. All right, let's take a look at this blue rectangular prism and this green rectangular prism. They are similar. First, they give you the area of the blue one, and they're asking you to find the area of the smaller one. Before we can do this problem, let's go ahead and list out all of the ratios. The side ratio is 12 to 5. The area ratio is 144 to 25. And then the volume ratio is 1,728 to 125. All right, of those three ratios, the one that you're going to use is the area one. There's the setup. The 144 over 25, that's the area. And then the 560 to x. Cross multiply and solve for the x. You should get about 97.222 inches squared. Let's do another example. This time they give you the volume of the green one. So we're going to use the volume ratio. 1,728 over 125. And notice this time the x is on top. You always want to stay consistent. Notice in the entire problem I've been going from blue to green. Always from blue to green. You can go either way, but as soon as you choose one way, you have to stick to that way. And notice that's why I'm always going from blue to green, staying consistent in the entire problem. Solving that out using cross multiplication, the volume of the blue is 276.48 inches cubed. Let's go backwards with this example. Notice we have cylinders and they are giving you the volume of the big one and the volume of the small one. We have to find the ratio of the sides, the surface area, and the volume. But this time they give you the volume, so we start off at the volume one, 125 to 8. How do we go back to get the ratio of the sides? Think about it. To go backwards, you have to do something called cubed root. What times what times what gave you 125? And then what times what times what gave you 8? Think about it. It's 5 and 2. 5 times 5 times 5 is 125. And then 2 times 2 times 2 is 8. And then from there, you should be able to find the surface area pretty easy. Just square that. 25 to 4. All right. I think that is all we have for today. Good job.